Hi everyone, welcome back to the channel, and today is on Leetcode daily challenge problem number 543, diameter of a binary tree. So it is a very easy problem to solve, and we'll first check out the problem statement, then we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get a root of a binary tree and we have to return the length of diameter of tree, and they have defined the diameter of a binary tree, which is the length of the longest path between any two nodes in a tree. Okay, this path may or may not pass through the root. Okay, the length of a path between two nodes is represented by number of edges between them, and they have given this example. For example, in this case the longest path is this one, 4213. Okay, because we have three edges in it, or you can also say 5213 because it has the same number of edges. So this is what we have to do. Let's check out the approach which we can use to solve this problem. Okay, so we will be using DFS and recursion to solve this problem, and what we will do essentially is uh, we will take each node and we'll try to get the longest we can go on the left side of it, and the maximum we can go on the right side of it. For example, uh, we are at the root node, okay, and we will check what is the longest length on the left side of it, which is this one, or it can be this one as well, so the length on left is what, 2. Okay, we'll similarly check what is the deepest I can go on the right side, which is 1. Okay, so we will basically sum up these two values, and we can say, okay, so if we take this node, this will be the longest path having this particular node. Okay, and we can use all the nodes to do the same, and figure out which is the longest path. So yeah, this is the question, and the exact same logic will be applied on all the nodes. So let's just check out the code directly. So here what we have done, we have used a result variable and we have initialized it with 0, and after that, like, we have defined a DFS function which we will be calling recursively on the left subpart and the right subpart of the current node. Okay, I have used non-local res here because I was getting some scope issues with the results, so I just simply googled the solution, and this was the solution I was able to come up with. After that, like, we are checking if the root is valid or not, like if we are not getting none. Okay, in case of nuns we will just simply return 0. Otherwise we will try to go on the left side and on the right side of the current node. Okay, so to go on the left side recursively, simply we'll call the DFS method which we have defined, and we'll go root dot left. Okay, if it is a none node or a null node, we will return 0 from that side, and we will basically know that okay, we have reached to the end. Similarly on the right as well, we are doing the exact same thing, and the result from that point, or including that node, will be maximum of current result. Okay, like, whatever result is there in this variable, or left plus right. This is what we saw in the explanation as well, right? So the whatever the maximum of these two values are is will be the new result, and at the end we are just simply returning 1 plus maximum of left and right as a answer for this DFS method. Towards the end, we are just simply initiating the DFS, the recursion call with the root node, and at the end, we are simply just returning the result variable which we have defined to store the results. Let's check out the test cases. Um, so as you can see, both the test cases got clear. Let's submit it for further evaluation. And yep, so as you can see, the solution got accepted, and also, like, we have performed decent. So yeah, this was the solution, guys. Thanks again for watching out the video. Stay tuned with upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.